Hi everyone, Dr. Mike here. In this video, we're taking a look at an overview of the female reproductive cycle. We're going to take a look at what's happening at the ovary, what's happening at the uterus, what's happening in regards to all the various hormones that are being released, and a lot more. Let's take a look. Now to begin, we need to understand that the female reproductive cycle is actually two major cycles. It's what's happening inside the ovary, so the ovarian cycle, but also what's happening at the uterus, so the endometrial cycle. Both of these two things are super important. So we're going to take a look at the ovarian and uterine cycle and the various changes that occur associated with each. And we're going to have a look at the various hormones associated with these changes as well. Now to begin, we need to understand that the ovarian and uterine cycles, or the female reproductive cycle, goes from 0 days to 28 days. Now this is an approximate. It can be lower, it can be higher, but only by a little bit. It could probably be as low as 25 days and as high as 34-ish days, but it's variable. The average is 0 to 28. So we're taking a look at the 0 to 28 female reproductive cycle. First of which is the ovarian cycle. So remember that there are many things happening in the ovaries. What's happening is that this is where our oocytes are, our egg cells. Now this is where the genetic material resides, and this genetic material needs to replicate. It needs to undergo 2 phases of meiosis, but it also needs to be nourished and protected. And so this is what's happening in the ovarian cycle is follicular genesis, which is the development of the follicles that protect the egg, but then also what happens after the egg is ovulated. We're going to have a look at the endometrial cycle as well. So this is what's happening at the uterus to prepare it for implantation, and the hormones. Ovarian cycle to begin with. There are 2 major phases associated with the ovarian cycle. The first phase is that of what we call the follicular phase. The follicular phase. The second phase is what we call the luteal phase. The luteal phase. Now, as you can see, because I've broken it up in accordance with days here, that from 0 to 14, we have the follicular phase. And then from day 14 to 28, we have the luteal phase. Let's take a look at this to begin with, because the follicular phase is associated with taking the oocyte, or the egg for example. So here's the oocyte or egg in a primordial form. Now that primordial oocyte will turn into a primary oocyte, and this primary oocyte, and I'm not going to write that up yet, this primary oocyte is surrounded by a thin layer of cells, and this thin layer of cells we call pregranulosa cells. Pregranulosa cells. And the whole thing with the pregranulosa cells and the oocyte, and this is called a primary oocyte, this is called a primordial follicle. Primordial follicle. Now this primordial follicle will start to mature and develop. And over time, what's going to happen throughout this follicular phase, so going from day 0 to day 14, is this primordial follicle will get that oocyte, and those pregranulosa cells will turn into granulosa cells, more cuboidal shaped cells. And the oocyte will be surrounded by this thing called a zona pellucida, which helps protect it and is very important when it comes to fertilization. Once the sperm gets into that zona pellucida, it's like the screen doors of the house all shut and don't let any more sperm in. So now we've got these granulosa cells, and we've got the zona pellucida as well, zona pellucida. And this is what we call a primary follicle. So it goes from a primordial follicle to a primary follicle. Now, this whole time, it's still a primary oocyte. So don't get that confused even though the follicle name changes. It goes from a primary follicle into a secondary follicle. And the secondary follicle is very similar, still has the zona pellucida, except there's one major change. Well, a couple. First of which is you can have a couple of layers of granulosa cells. So I'm just going to draw it up like this. And you're going to have some additional cells called theca cells. So you have these theca cells now on the outside here. So these are theca cells. And you still have your granulosa cells and you still have your zona pellucida. Granulosa cells. This now is called a secondary follicle. Secondary follicle. And this secondary follicle will turn into, now I haven't told you about what they do, I will, I promise, I'm just going through the phases. The secondary follicle will turn into a mature, ultimately a mature follicle. Now what this mature follicle does by day 14 is it ovulates. Now what that means is that you have these granular cells like this. You have these theca cells that have now developed even further, right, on the outside. And the oocyte has ovulated. And it takes some cells with it because it still needs to be nourished, right? Now that's an important point because I haven't told you what any of these cells do. As it goes from day 0 to day 14, the development of this follicle, well, these follicles, which we call the follicular phase, from a primordial follicle to a primary follicle to a secondary follicle to what we call a mature or Graafian. So let's call this an antral, or let's call it a Graafian, or you could even call it a mature follicle, right? This is the one that ovulates. Now the granulosa cells and the theca cells are super important. What the granulosa and theca cells do is they ultimately produce estrogen. Now specifically, one type of estrogen that's most important here is called estradiol. Now here's the thing. This whole process, going from here to around about here, is independent of any hormones. It really doesn't need hormones to do this, right? Now, if we have a look down and look at the hormones, what's happening during this process? Let's first focus on luteinizing hormone and follicle stimulating hormone. Now remember, these hormones, these two here, they're ultimately released from the hypothalamus, right? Specifically, they're released from the anterior pituitary gland. So what happens is the hypothalamus will release a hormone called gonadotropin releasing hormone, and this goes down to the anterior aspect of the pituitary gland, which then releases these hormones. This happens at puberty, right? Now let's have a look at what's happening at these hormones. Luteinizing hormone and follicle stimulating hormone, they're not super high, right? Let's start with follicle stimulating hormone. So what you'll find here is that follicle stimulating hormone at day 0 is up here and it starts to drop down, right? Let's do the same with luteinizing hormone, right? Luteinizing hormone, it's here and it starts to drop down slowly. Interesting. Now, importantly, what these two hormones do, most specifically follicle stimulating hormone, is by the time we hit this phase here, we need follicle stimulating hormone to stimulate these secondary follicles to turn into more mature follicles, to these antral follicles, Graafian follicles, more mature follicles. We need FSH for this. If FSH isn't here at this step, what ends up happening is these cells just all die off. Now every month, right, at day 0, you have around about 10 to 30 of these follicles undergoing this process. And again, without FSH, they'll all just undergo atresia and die. So what you'll find is that because FSH is released, it allows for that selection process. Now here's the other thing that's important. As it selects, and it's going to take from 10 to 30, it's only going to select one, right? One mature one to ovulate one single ovum. As it does this and these granulosa and theca cells get bigger and bigger and bigger, these granulosa and theca cells produce estrogen. So as the follicle develops, the estrogen, right, estradiol specifically, it starts low, but it starts to go higher. Now, can you see a pattern here, right? As the estrogen gets higher, the FSH and LH gets lower. This is important because the estrogen that's released from these theca and granulosa cells goes back to the hypothalamus and says, and provides negative feedback, says stop releasing gonadotropin releasing hormone, stop releasing luteinizing hormone and follicle stimulating hormone. Why would it want to do that? It does that because it's now already selected its one mature follicle that it wants. So there's no point continually releasing these hormones to keep this process happening. We want these to stop and just have that one selected one. Now the estrogen will continue to go up and inhibit the FSH and LH until something important happens, right? So again, we're not at day 14 yet. We're not at this point. What we're going to find is as we get just maybe like 24 hours before day 14, the estrogen levels that are released by these theca and granulosa cells, it starts to just spike right up. Now here's the interesting thing. While relatively low levels of estrogen inhibit FSH and LH, high levels of estrogen stimulate them. We don't know why, but it does. And so when we have this higher level of estrogen and it stimulates FSH and LH, what we end up getting is the FSH down here and the LH down here. But once it starts to get, right, once these levels start to get high enough, we get a surge. Now, the surge in this case predominantly is going to be that of luteinizing hormone. We also get a surge of FSH. But importantly, we've got this big surge of LH. And again, this big surge of LH is happening just before day 14. And what this big surge of LH does is FSH, follicle stimulating hormone, is really important in the follicular phase. That makes sense, right? So FSH is really important in this phase. Here, at day 14 where we have ovulation, let's write that down, I think that's important. Day 14 where we have ovulation occurring, this is important because of LH. LH is responsible for that ovulation. Beautiful. So that's because of that spike there. Now the thing is that once this happens, we've got the ovulation occurring, the egg has been taken up by the fimbriae and is now in the uterine tube, right? The fallopian tube. Let's just have a look here, right? This remaining thing here, if I were to draw it across, we're now in the luteal phase, right? So we've now got this big empty looking body, and this big empty looking body starts to produce a whole bunch of progesterone. This is called the corpus luteum, hence why it's called the luteal phase. So this is called the corpus. Corpus means body, right? Luteum. Luteal means yellow. It looks yellow, right? Because cholesterol, we turn cholesterol into progesterone, and we turn progesterone into androgens, right, like testosterone, and we turn androgens into estrogen, like estradiol. All comes from cholesterol. So what's happening in this corpus luteum phase that goes throughout this process here is it starts to produce huge amounts of progesterone. So what we end up getting is low levels of progesterone through most of this process. We have a little bit of a spike here. But once we hit day 14 and this corpus luteum happens, we get this big spike of progesterone, right? We get this big spike of progesterone. What happens with all these other ones is they start to drop off again. So we've got estrogen dropping off, we've got follicle stimulating hormone dropping off, and we've got, luteinizing hormone dropping off, and we've got follicle stimulating hormone dropping off. But here, for this luteal phase, we've got heaps of progesterone. All right, we haven't spoken at all about what's happening in the endometrium so far. endometrial lining, or the endometrium, or the uterus, has three major phases. The first phase is called menses, and this is bleeding. Now, as you can see, menses goes to around about day 5. And then after bleeding, after menses, we've got the proliferative phase. Proliferative. And then we've got the secretory phase. Now remember, this is what's happening at the endometrium, the secretory phase. So if we look at endometrial changes that occur, so just so we've got enough room, I'm going to drop these. Because I didn't do units, it's okay. I'm just looking at gross changes that happen. So that's not a problem. I didn't do any units on purpose. And it's important to understand the unit changes here because some are measured in microliters, micrograms per microliter or mil. Some are measured in picograms, nanograms. So they're all you can't compare them in regards to their concentrations. This is just general spikes, for example, and peaks and troughs. Now the endometrium, what happens? Menses. Menses is bleeding, goes for about 5 days. If we have a look at the thickness of the uterus, like this, it's going to be thick and then it starts to bleed away and slough off. So if this whole thing was what we call the functional layer of the endometrial lining, we're focusing on the functional layer. The functional layer is the layer that can implant the fertilized embryo, but also can thicken, become more vascularized and produce enzymes and various secretions like mucus. During menses, the uterine lining gets thinner and that's because bleeding is occurring. It's sloughing off. This sloughing off is happening because the hormone levels are really low. That's important. But as you can see, in the proliferative phase, it starts to get thicker again. Now it's getting thicker again because we're starting to get an increase in estrogen levels. What estrogen does is it increases the thickness of the endometrium, right? So it starts to get thicker. That's great. As you can see, as we move through, and not just estrogen is being produced, we now start getting progesterone. Progesterone reinforces this and says, hey, endometrium, get thicker, get more vascularized, and so here we've got the proliferative phase. This is simply just saying get thicker, get thicker, get thicker, get thicker, right? Then the secretory phase is saying now start to develop glands. Start to develop glands, and this is in big part due to progesterone, that we can now produce enzymes, that we can now produce mucus and so forth. And then what we end up getting is, once these hormones like progesterone start to drop back down again towards 28 days, and once estrogens drop back down again, and then once follicle stimulating hormone, luteinizing hormone have dropped back down again, the hormones are low again at the end of day 28. And like I said, the low hormones is what causes the sloughing. So towards the end of day 28, we start to get that drop down again. So we've got menses, which is bleeding. That's happening at this stage. Proliferation, this is, all right, so let's think about it like this, right? Follicular phase is very much so due to FSH. Luteal phase is very much due to LH. Like I said, FSH helps to produce estrogen, right? So the proliferative phase is really important when it comes, estrogen is really important when it comes to the proliferative phase. The secretory phase, luteinizing hormone, which produces ovulation of the corpus luteum and ultimately produces heaps of progesterone, is very much so due to progesterone. Now there's a huge amount of overlap, obviously, because LH is important here and FSH is important here, progesterone is important here and estrogen is important here. But broadly, generally speaking, these are the important hormones involved mostly in these cycles or these phases of the cycles. So importantly, day 14, ovulation. Right? Day 28, hormone levels go low again. From day 0, they start to go back up. Estrogen is inversely proportional to the FSH and LH, so the gonadotropins, until the estrogen levels get quite high, then they both spike. That spiking of the LH, maybe 24 hours before day 14, is what stimulates ultimately ovulation to occur. The LH helps stimulate the corpus luteum to produce progesterone, and this progesterone, as you can see, will last around about 10 days. right? So this progesterone is really important. Lasts around about 10 days-ish and then drops back down. Why? Well, this corpus luteum will release the progesterone for around about the 10 days. And what it's doing is it's basically said to the egg that it's ovulated. Remember, where's this egg now? This egg has gone into the fimbriae and has been taken in and is in the uterine tube, and it's in the ampulla, and hopefully fertilization occurs. If fertilization by sperm occurs, that egg, which then starts to grow and divide as it moves through the uterine tube, can hopefully implant in this nice thick endometrium that's developed, right? In this window-ish here. So we've got this important window here where it needs to implant. And so we've got this progesterone being released to keep the endometrium nice and thick for that implantation window. But if there's no sperm and there's no fertilization, there's no implantation, what ends up happening is that if it does get fertilized and implanted, it starts to produce a hormone called human chorionic gonadotropin. So if it does implant, right, if it does implant and start to divide and so forth, it will release human chorionic gonadotropin. Basically, it pretends to be gonadotropin. And it is like a phone call back to the corpus luteum saying, hey, everything's good, I'm here, keep producing progesterone. So if that does get implanted, that doesn't stop at 28 days, it keeps going. That means if it keeps going, it stays thick so that the embryo can develop and you don't get menses, you don't get bleeding. But if there's no implantation, there's no human chorionic gonadotropin, there's no phone call back, after 10 days, it stops producing progesterone and the tissue starts to diminish and sloughs away. You get bleeding, that's menses, the whole cycle starts again. So I hope that this helps and this makes sense. Hi everyone, Dr. Mike here. If you enjoyed this video, please hit like and subscribe. We've got hundreds of others just like this. If you want to contact us, please do so on social media. We are on Instagram, Twitter, and TikTok at Dr. Mike Todorovic, at DrMiketodorovic. Speak to you soon.